Let's consider the solution of this initial value problem, y double prime minus 6y prime plus 9y equals g of t, where the function g is not specified. So to do this, we'll take the Laplace transform on both sides. On the left side, we have s squared y of s minus 6y of 0 minus y prime of 0 minus 6 times sy of s minus y of 0 plus 9y of s equals the Laplace transform of g, which for now we'll just say is g of s. Okay, now the objective remains the same. We solve for y of s. So on the left we have s squared minus 6s plus 9 y of s, combining these three terms. On the right-hand side, we'll bring this over to the right, so that's going to be 3s. We'll bring this over to the right, plus 4y. Then we'll also bring this over, so that's minus 6 times 3, or times negative 3, for plus 18 on the left. When I bring it over to the right, it becomes minus 18, plus g of s. And so solving for y, we get y of s is equal to 3s minus 14 all over s minus 3 squared, that's a square, plus g of s times 1 over s minus 3 squared, where I'm going to deliberately write this as a product. Okay, now before we worry about the inverse Laplace transform, let me work with this. So I need the partial fraction decomposition for this. Now I could set this up as a over s minus 3 plus b over s minus 3 squared. For this particular problem, it's actually easiest to simply write out the decomposition. If I had an s minus 3 on top, then that would cancel out one of the squares in the bottom. Okay, now that's not quite right, because 3 times negative 3 is negative 9. So I need another minus 5 to compensate. Plus g of s times 1 over s minus 3 squared. And so this becomes 3 over s minus 3 minus 5 over s minus 3 squared plus g of s times 1 over s minus 3 squared. So that is the Laplace transform. We now find the inverse Laplace transform. The inverse Laplace transform of this first fraction is 3e to the 3t. The inverse Laplace transform of this function, it's 5 times 1 factorial on top. So we have 5t to the first, e to the 3t. Now the inverse Laplace transform of this product is going to be a convolution integral. The inverse Laplace transform of capital G is the function little g. The inverse Laplace transform of this function is what I see here, t e to the 3t. And so the inverse Laplace transform of this product is integral from 0 to t of, taking the inverse Laplace transform of this function, we get u e to the 3u. Then we have the inverse Laplace transform of this function, g of t minus u, putting t minus u instead of u, du. And that's the answer. Another acceptable answer would be to write it instead as integral from 0 to t, using this function first, g of u, and then using this function second, replacing u by t minus u. So t minus u, e to the 3 t minus u du. And then the other two terms are the same. So either one of these would be an acceptable final answer for the solution of this differential equation.